Welcome to Building 72, the podcast brought to you by the Entertainment Arts and Engineering program at the University of Utah. Thank you for joining your hosts, Adam Hunter and Corinne Lewis, to talk about the video game industry and, probably other stuff.
Hi, everybody. Welcome back to Building 72. I just did this clappy thing and Adam laughed at me. We are so excited to be here again today. And I have a good friend of mine, Adam is here, but my good friend Tony Kanell is also here.
Well, I was going to say, he's also now a good friend of mine. You can't just like co-opt this friendship.
Oh, sorry.
It's not exclusive.
Tony is everyone's friend, really.
It's true. It's true.
So thank you so much, Tony, for coming to do this. Adam and I are having such a good time talking to everybody. And this is such a strange time to be in the game industry, but we're kind of getting through it together. Although Adam and I are tangentially in the game industry. But will you introduce yourself and tell everybody what you're currently doing?
Sure. So my name is Tony Kanell. I am the technical program manager at Nvidia in charge of ray tracing for professional visualization. So what that means is we, as a company, maintain 3 different APIs for ray tracing. So DXR, which is used for gaming, optics, which is used for film rendering primarily, but it's also used in simulation and some other areas. And then another open source library called Vulkan, which has ray tracing plugins. So basically anything that has to do with rendering and ray tracing goes through our group in some way. And so as a program manager, I'm in charge of schedules and the product itself, maintaining what we work on and what we don't. There's a management team of engineering managers and QA managers and everyone else that I work with to kind of see that product from start to finish. And then we have a large engineering team sitting in a whole bunch of locations. We have people in Santa Clara, here in Salt Lake City, people in Berlin, and we all kind of work together to make that happen. And so I've been at Nvidia for 2.5 years or so. I was at EA for a long time working on The Sims. I'm a University of Utah graduate as well. Went through before EAE existed, but took a lot of the same classes that eventually became what is the core of the program now. Worked a lot with Bob and Corinne and lots of people before all that kind of came around. So I really like working with everyone here, and it's been a lot of fun.
Yeah, I don't know if we've ever said that before, but AJ Dimmick, who is one of our alumni, but also is our esports director, he calls you guys Kesslerites.
Right. The pre-cohort people.
You're one of the Kesslerites. I did not know that. That is very interesting. There is now a whole bunch of like emotional baggage that has now just been dumped because you've been associated with that game.
Yeah. So, I mean, we were taking, I can't remember which of Bob's classes we were taking, but he said, "Hey, I've got this thing I want to talk to a couple of you guys about after class. So stick around." And he said, "I've got this idea for what is going to start out as a class, but I hope it's bigger." And he pitched to a group of students his machinima class, which was kind of the first thing that launched into, what EAE is now. And I think there was maybe 10 of us in that very first class. And so we took machinima first, and then we took Mark's modeling class, and then he created machinima 2 class after that. And we had created some movies that Bob used to take in front of the board and kind of show, hey, this is a thing and it's possible, and all sorts of stuff. So there's a long history of that. And so it's, I don't know how many, it's been maybe 15 years-ish, maybe longer.
At least that, right? Or maybe 14 years. Bob would know. What's really funny, Tony, you don't know this, but so Bob was at a conference and they were talking about Half-Life, modding Half-Life, and how they thought that this would be a good thing for people in universities to teach kids. And at that exact conference, so Bob was taking pictures, and he has a picture of Michael Young, who is our new director, in that room at that time. So he wasn't with the EAE, but he was in the same room where Bob got all that information.
That's too funny.
I know.
That's
It's like next time we hire somebody, they have to have been in that room, apparently. So, okay. So let's get to the two ferns portion.
Well,
Okay.
I've got a question right off the bat, Tony.
You bet,
Sure.
Adam.
You say
Fire
you're a
away.
technical program manager, and what you described, that sounds like it's actually a lot more of maybe production related stuff or managerial related stuff.
Yeah.
So I guess my question is twofold. Is you explained like you went to EA and you worked on The Sims and things like that. So I guess question one is, how did you get into that role from being like an engineer? And then two, do you like that role more so, less so? Is there anything like, do you miss going back to just the old like crunching away at code and stuff like that?
Yeah. So my role is probably pretty unique within the industry. I think there are very few people who like to do what I do. So it's maybe to go back in time a little bit, when I was in school and taking Bob's classes and all of these things, I needed a way to pay for all of it, right? Like most kids in college. And I didn't really want to go and get a regular job and all of these things. So I decided that it would be a good idea to just start a web development company. And I hired most of the other Kesslerites as my employees, and we built websites. And so as kind of the owner of this company, I had to go and drum up the business and talk to the clients and make sure that we had a pipeline of things to do, so that all of these people who were in my CS classes, could pay their tuition at the end of the semester. And, so I have a CS degree. When I was at EA, I was the lead engineer on The Sims 3, a really deeply technical background, but I've always really enjoyed kind of that stepping out of the technical aspect of things and keeping all of the plates spinning, and dealing with the kind of managerial side of things, and more particularly the kind of personnel side of things, where, what is this person working on? What are they best at working on? How can I, find things that fit that person's skill set? And as a team, we can all kind of succeed together. And I think as much as I try and lean into that part of my career, there are lots of people who do that, but there are very few people who also at a technical level understand, what a BVH builder is and how it leverages, the RT cores on Nvidia GPU and why that's important, and so those two things together always end up pulling me back into technical leadership as well. And so Nvidia is a great example. I started out there as an individual contributor. I wasn't managing anybody, and I was solely in charge of just the product, right? I was managing deadlines and, interfacing with the other driver teams. But, a couple of years later, I now have a good portion of the team in Salt Lake reports to me directly. And, they're all engineers, and I'm their technical leader and other things like that. And it just kind of naturally flows that way for me. And so even though on paper, the job is much more managerial and kind of not technical at all, just given my background and the way things are, I kind of end up back in that position naturally, just because of where I've been and what I do. And so it kind of lets me be unique and do the things that I do well. And I think that it ends up being super valuable for the companies that I've been at. So it's kind of interesting.
And so you super like it, it sounds like.
I do. I really, really love it. And, I've worked at a lot of different places, and they've all kind of brought different things to the table. And Nvidia is definitely unique in that, this has happened more than a few times where we have our company Slack channels and there's like a random channel where people just discuss whatever. And, someone will say, hey, I bought this book over the weekend and I'm reading about X topic and I can't really understand, what they're saying about this. And lo and behold, the author of said book works at Nvidia and says, well, actually what I meant was,
Oh my gosh.
and this conversation breaks out in the Slack channel. And it's, like that level of expertise, luminaries in every field, they all exist in one place and kind of feed off of each other. And just the level of excellence of the people who work at Nvidia is so high. And so it's been just a delight to be able to work with people of that caliber.
Wow, that sounds like so fun. I think it must feel a lot like working on a campus with a bunch of it's one of my favorite things about being an academic is like I work with super smart people who know way more about, it's perfect for me because I like learning things. And so it's like, you can just still be a sponge, even though I know things now, but I also still love learning things.
And that's like the people that I've known in my own life and everything like that, the people who are really thriving, not only in the game industry, but creative industry, tech industry, they're the people who are always the ones who because technology is always going to advance. So there's always going to be there's going to be this thing called ray tracing, which is this fancy new thing, right? And so the people who are the ones who get the most satisfaction and the ones who thrive are the people who always want to be the best version of themselves. That sounds very like self-help book, but you know what I mean? They're the people who are always wanting to learn and always wanting to be the master of their craft.
Yeah. And I think that it's one of the things that's most appealing to me about this industry in general is just that, just given how competitive it is, those types of people tend to be the ones who make it in. And so you have this group of just extremely driven and dedicated and, people who are willing to go the extra mile to do what they do. And it really is different than people who are just coming to work to collect a paycheck and, live their lives outside of work. And, there's that's great for the industries that do that, but it's really something special to be a part of when you get to come to work with people who are like-minded and passionate and dedicated. And it's really quite unique.
Yep. I 100% agree. So I'm going to ask you a very simple yet complicated question.
Sure.
And this is coming from someone who is, I'm not a math person. And every time I've tried to learn HTML or something like that, it makes my brain hurt a little bit. Why do you like programming?
It's a really good question, actually.
Yeah, it is a good question. And I think for a lot of people, it's tedious and, difficult, and, the pain is just not worth it. But for me, the thing that is really rewarding and the reason why I keep at it is that it's an act of creation, just the same way that, an artist feels that satisfaction having completed a piece, a painting or whatever. I feel the same way after I finish some project that I'm working on. And I really think it's why games specifically speak to me, is that at the end of the day, you have this thing that you can experience, right? It's tangible. It's, exactly how your code went into making that thing real. And so when you're working through the difficulties of programming, when you're debugging and it just doesn't work, or when it's hard or confusing or whatever, the rewarding side of it really, of being able to sit down and play with something and see it actually working, that's the part that pays off for me. And, even now where we work on APIs, which are super low level, and we don't even hand them to customers, right? We don't see people enjoying them directly. We hand them to developers, and then developers make games on top of them, and then people eventually enjoy them. It still is extremely rewarding because we're working every day directly with these developers, and we're solving problems that they have, and we're opening up new roadways for them to do things that they've never been able to do before. And when I say it's an active creation, it literally is. Yesterday you couldn't do this thing, and today you can because of the work that someone did. And so it's extremely rewarding to have brand new opportunities created by your work. And so that's the thing that drives me as a programmer, is being able to go in and make something that did not exist before.
That's cool. I think I've actually heard you describe it as it's the most complex puzzle that you in a game that you could ever try to solve. And you also get to make a game at the same time.
Absolutely.
So that's actually a question that I want to kind of follow up on, and hopefully I can voice what's in my head out of my mouth properly. So it's an act of creation, and you take a sense of pride in having accomplished something. Is there a lot of, it's going to be a very similar word, is there a lot of creativity in program and like creative freedom, or is it more like construction work of like, hey, I built a house because there's standards and now here's my house? Or is there like, there's like 5 different ways that we could go about accomplishing X, Y, and Z, and so I have to take into account how expensive it is, and is there creativity behind that creation, if that makes sense?
I think that there's an immense amount of creativity in the way that you go about solving these problems. And I think that especially with when you're tackling a problem that is unknown, right? There's more than one way to skin a cat, I guess, is the famous adage. When you're doing something that has never been done before, there's a million ways you can approach it. Whereas, if you're trying to do pathfinding in a game, for example, right? You have a character and you need to get him from point A to point B. It's a pretty well solved problem, right? Yeah. Everyone uses A* with path compression or whatever the algorithm is of the day. And so that's not, for me, all that exciting. That's just kind of work, right? You're going and you're doing something that everyone knows how to do. And it's like showing up to the work site and here's your pile of dirt, just dig, right? Uh-huh. And that's less exciting to me than, hey, here's this thing that we don't really know if it can be done, but we would really like it. So figure out a way to do it. And those are the parts that I feel like you get to exercise your creativity, because you're working with, you have constraints within the system, and there are only a couple of solutions that will work, but you have to find them, and you have to find the one that works the best with the design goals that you have, and the resources that you have available, and whatever else you're dealing with. And so I do feel like there's a lot of creativity involved there.
That's really cool. I don't think I've ever heard it described in that way. I really like that.
I always think about that when you talk about elegant code. Elegance is a subjective thing, right? And so when I just think that I love that term, because I think it denotes how much creativity you can have as a programmer, because it does feel like when you're not a programmer, when you're outside of it, it does feel like, oh, that's just math and that sounds terrible, unless it sounds interesting to you, and then you should be a programmer. But did you always want to be a programmer before when you were a kid?
Yeah. So,
you're old enough that that's possible, right?
Yeah. So,
or young enough, I should say.
Let's see. I was in 5th grade, so I was 10, and my elementary school got some extra funding from the district where they were going to take 4 students and teach them to program. So they took the 4 kids with the highest test scores in math and science, and they pulled us out into this little group to teach us BASIC, which was a language from a million years ago. And they had this guy from the district come down, and he came for 2 lessons, and he taught us if statements and variables. Those are the two lessons that he taught us. And then I don't really know what happened. I don't know if schedules got mixed up or the funding ran out, but he stopped showing up and no one told our school that he wasn't coming anymore. And the other three kids happened to be my three best friends. And so we were not about to tell our teacher that this room with a computer that they let us go to for 2 hours every day suddenly didn't have an adult in it. And so we just kept going, and they had bought us a book on BASIC, and we had a computer with a compiler in it. And two of the samples that were included with the compiler to teach you how to write BASIC were Nibbles, which is that old snake game for your phone, and a game called Guerrilla Warfare, where you throw bananas at each other and they'd explode. And there were four of us, and both of those games were 2-player games, which is a fundamental problem. And so for the rest of the year, we tried to figure out how to rewrite those games to be 4-player games.
That's
so that
amazing.
we all could play at the same time. And so we got Nibbles working with 4 players in a month or so. And so if you can imagine 4 10-year-olds around a keyboard trying to make their snakes go around. And we never got Guerrilla Warfare to work with 4 players because it used sprites and stuff to do the animations and it was just a little bit over our heads, and we didn't know how to like create new art assets, but we tried. But like from that moment on, I was just like, this is it, right? Like if I have to go to work for the rest of my life, like this is what I'm doing. And it sounds naive and idealistic as a 10-year-old, but that really was how it was for me. And so every opportunity that I had to learn programming, we'd ride our bikes to Barnes and Noble and we'd find the Pascal for Dummies book and we'd just sit there and read it. And then, finally, when I started getting into high school age, they started offering programming classes that I could take. And I got as many of those as I could and all sorts of stuff. So it really was something that I've known for ever and ever. This is what I wanted to do.
I just love that that's the foundation of your game, what you're doing, because that's exactly what game development is. It's like, I think that there's a problem here. Let's try to solve it with a bunch of people who don't know how to do what they're doing.
Exactly.
So we're just learning as we go. It's fine.
Because none of us is as dumb as all of us put together. So.
And I mean, the way we started out, right? Like we knew how the search function worked. And so we just Control F, player 1, and everywhere there was a player 1 variable, we added a player 3 and a player 4. And then we tried to compile it and it did not work. And so fixed all of our compiler errors. And then we had to walk through the logic and be like, okay, just adding variables doesn't actually add a player. And so it was just a total trial and error to figure it out. But eventually we got it working.
That's amazing.
That is the first 10 minutes of a movie about like someone who goes on to be like a hero in the world of
totally. It's a great origin story.
The 80s flashback of riding the bikes and going to the coding class. And that is fantastic. So here's a good question for you. So you mentioned BASIC, which my knowledge of BASIC kind of begins and ends with the like 3 Futurama jokes that they've mentioned where they've talked about BASIC. How has programming, I mean, obviously different languages and things like that and different hardware, but have there been any big like fundamental changes in programming since you've been interested in it? Or is there things that you see like on the forecast, how has the world of programming changed over the years that you've been doing it, or has it changed at all?
Like what you see on the screen in front of you is largely the same, right? Like BASIC is a C dialect. It kind of, right? The variables and the statements and everything looks largely the same. It uses subroutines instead of function calls. And I'm sure the memory model is different, but largely if you could read C code, you can read BASIC. And if you can read BASIC, then you can read Pascal like that. The syntax of one language over another, I don't think changes really between one or the other. And so I don't think that has drastically changed. I think some of the things that have changed is just the accessibility, right? Because I remember we had this this computer with a compiler on it, and I wanted to go home and do the same thing on my computer. And we had a computer, right? We had an 8086 ancient computer with DOS on it, but we didn't have a compiler. And the Borland compiler was $975, you know? And I told my parents, hey, will you buy this for me? And they're like, no. Are you insane? No.
Oh my
What does it do?
gosh.
What does it do? Well, I typed some stuff in it and then some other stuff comes out on the screen, you know? And they were just like, no. But just the whole landscape of what it takes to get off the ground for learning how to code is the barrier to entry is functionally zero at this point. And so, you know, you can right size your code to your project now in so many more ways than you could then. Before it was like, yeah, well, I've got Java, which, you know, requires this, and I've got C and C++ that requires that. And those are kind of my only two options. And eventually, you know, C++ and some of these other things came along. But nowadays, there's so many different languages and options, and they all can kind of be fit to whatever project you need. And so, and largely, if you have experience in one, you can kind of get off the ground quickly into any of them. So it's much more accessible. It's much faster to do things. And the community behind all of them is massive, right? Like our way to learn things was literally to ride our bikes to Barnes and Noble and read books that we didn't own because that was the only way we could do it. And now it's a Google search away, and there's functionally limitless knowledge about everything you could possibly want to do.
Do you think, and this shows kind of how little, even though I've worked around programmers for a very long time, I'm not very good at like BSing programming speak. Are there a lot of things that we kind of had to worry about way back in the day about, like, you know, memory constraints or you know, characters on the screen and all these kind of things that were really taxing on early hardware? Do we still worry about those nowadays because now our characters have 20,000 polys on them? Or are there some things that, like, yeah, that was a deal, you know, maybe at the turn of the century, but in the past 20 years, we never have to worry about X anymore because we've kind of fundamentally solved that problem?
I think that there are a lot of things that we don't have to worry about anymore, and there are a lot of things that we still do. And it really depends on where you live in the pipeline, right? Because so where we're doing optimizations and where we're, you know, kind of focused on as API developers at Nvidia, we are literally counting instructions, right? And say, like, this set of code, when we compile it down to machine language, generates 10,000 instructions, and this one only generates 9,500. And when you amortize that over an entire, you know, application, that has a 1% increase in performance. And 1% might not sound like a lot, but Steve Parker, who is a former professor at the U and my boss currently, his saying that he always is saying is that Moore's law is only 1% a week, right?
Just once a week.
Just 1% a week, right? If you guys can optimize the code 1% a week, then we keep Moore's law alive.
Oh boy.
And it's true, right? Like, so for us down, you know, really, really close to the hardware, we care very much about the order in which you put your if statements in your code. It can matter greatly, because if your first if statement is checking a variable that's not in memory, all of your next ones have to wait until that memory call comes. But and all the other ones are in memory, you're wasting instructions. Whereas, you know, if you're way up in the gameplay layer and you're talking about, you know, draw calls for your models, or how many polys are on, you know, this model versus that model, and, you know, things like pre-baking ambient occlusion or normal maps and stuff like that, like we're getting to the point where hardware has kind of made those problems irrelevant, and artists generally don't have to worry about that, especially not as much as they used to, right? 15 years ago when we were working on, the Wii and the DS, we cared a lot about, texture sizes and stuff like that. And we were fretting over, 32-bit textures versus 64-bit textures, right? And now we're talking about things that are 10 times, 100 times as big as that, and it's kind of not a big deal. So I think we've evolved past a lot of those barriers, but it all just depends on where you're optimizing and what you're trying to do.
So are you still speaking in German to your team in Germany?
Yeah, it depends on who we're with and what's on and who's on the phone, but there are certainly a number of them who we speak German with.
That's so cool. The first time you told me, I was like, well, I could have actually, like, if I'd worked at Nvidia, I could have used the German that I learned in school.
Yeah, it's a lot of fun.
That's actually a really good, just like sub question really quickly. The kind of impression that a lot of people give nowadays is that our generation, the younger generation who's involved in tech, pretty much anyone who's involved in like the tech sphere and especially like the programming sphere, English is the common language. Is that a pretty common thing as far as, because we do have, international students who go back home and things like that.
It absolutely is. It's the de facto language for everyone who works at Nvidia and it functionally any tech company. However, I don't think that you can discount the value of speaking to someone in their native tongue.
Oh, of course.
And so, for me and for, the people who we have lots of members of our team who are in Berlin, and, if I'm the only American in a meeting and they can just speak German and they don't have to put in the extra effort of speaking in another language, I think they appreciate that. Mm-hmm. And so, I think there's value there, even if it's not required. Their English is infinitely better than my German, but and I also think there's some novelty for them because there are very few.
They talk about your accent after you leave the meeting. Oh, did you hear him say Munchen? Whoa.
There's just very few Americans who put forth the effort to learn their language. So I think they get some sort of a kick out of it.
Well, so that kind of segues into the other thing I was going to ask you is, what is your typical day like now? Is it meeting? I mean, are you solving technical problems?
Yeah. So my job is mostly, I'm the guy who keeps all the plates spinning, and I'm also, NVIDIA has 18,000 employees and our team is a few hundred employees. So we're a relatively small piece of the puzzle, manpower wise, but in terms of impact, especially on, marketing and what customers see, it's a very large part of the story that goes out to the customers, right? Ray tracing is very important to, what's happening in the game development world right now. And so there's a lot of communication that has to happen with other teams. And so I act as the primary liaison between all of the other modules. And so
you're in 100 meetings a day.
I'm in 100 meetings all day, every day, which is why I have all of this.
Yeah.
I'm basically the world's most boring Twitch streamer. I just go to meetings all day.
Well, that's actually, one of the things that students always want to know is, let's talk about crunch and how are you dealing with work-life balance? And maybe NVIDIA is a little different, but
we are. And so we release very often, right? We put out new drivers every other week-ish. And so for us, we prioritize things and we have testing infrastructure in place so that, we try and get the most critical fixes in and tested first. And very rarely are we ever pushing up against a deadline to get something out the door, because there's always another train that's leaving in a couple of days.
Right.
And so for us, there's no huge opportunity that we're going to miss, like a game developer who puts out a game every 4 years, right? And that event is extremely important and they can't miss it and they have to have everything done, and the build up and the, we don't have that really. And, we do have bigger pushes towards, we just released Ampere a couple of weeks ago, and there was certainly some effort that went into getting that out the door. But by the time it gets to the customers, we're kind of already long past the phase where we've had to fix bugs, right? Because we get the cards in-house, months in advance.
Right.
We get engineering samples and we're doing, emulation and stuff like that. So for us, it's just different. So my crunch here is almost non-existent. I've never felt the need to, stay up all night and push something out the door like we did in games all the time. Mm-hmm. We did that all the time.
Mm-hmm.
And so, however, the intensity of decisions is infinitely higher, right? Because if I break something and I put out a bad driver, literally every PC on planet Earth gets broken, right? The stakes for doing
that is
something,
a little stressful.
And no pressure. No pressure
yeah, the stakes for doing something wrong are so much higher than they were. So it's a different kind of pressure, and it's constant as opposed to kind of having pressure that ebbs and flows with your release.
Right.
And for a typical day, most of our testing is done in either Shanghai or Pune, India. And Pune, for example, is 12 and a half hours ahead of us. So I don't know why
it's a half. I know my husband has people there too right now, and it's like, what?
Yeah. So, and then, like I said, a good portion of our team is in Berlin. So we start early. I typically have meetings that start around 7 in the morning, and then they go pretty constant until noon when Europe goes to sleep. And then my afternoons are usually pretty open for me to either meet with my team here in Salt Lake or, get work done that I have assigned to me specifically. And then sometimes I do have meetings late at night when I'm trying to catch up with people, in Asia, right. Whether it's Shanghai or wherever. So, yeah, like I attend a lot of meetings. A lot of them are mostly just informational to make sure that I catch anything critical that flies by, because like I say, I'm in charge of communicating big changes to the team or being there to answer questions if another module needs to know what ray tracing is doing or has questions. And so a lot of the meetings I'm there and I listen, but I don't have to present or I don't have to, be in charge and run the meeting. So it's not too stressful, but it just varies on what's going on.
Interesting.
So when you mentioned stress in the workplace, this probably isn't something you're dealing with now, but it maybe is something that you dealt with earlier in your career. Is there a lot of competition between like yourself and other programmers, whether that's between companies or within your own company? Is there a competitive aspect to it at all?
I think so. And I think that a lot of that stems from just the personality types who end up in the industry. I think that, we open up a job at EA, for example, we'd open up a gameplay engineer position and we'd get literally 1,000 resumes, in a week. And so when you kind of distill that down and pick the top people out of there, you generally end up with personality types who have, made this their life's work or who have, really gone the extra mile. And so you end up with a lot of people who are used to being the smartest person in the room their whole lives. And now suddenly they're in this room where everyone feels that way. And so there's a lot of personality clashes that can happen where people want to do things their way and someone has a different opinion about how things can be done. I think it really all depends on the team culture. And, it really only takes a few of these instances to define a team culture, and it's up to, the previous members of the team to show people how these things get resolved, to the team leadership to make sure that these things get resolved properly. Because I can think of some teams where we've had kind of an adversarial relationship between engineers and it did not go well, right? People, it's really hard to work well as a team when people don't trust each other. People are trying to, form groups to, win favor for their ideas and all of that kind of political mess. And I've worked on teams where everybody is working towards the same goal and you're all on the same page. And even though there's disagreements, you can come together to find the right answer. And those teams are always infinitely more successful than the other ones. And so, I think that sometimes the competition can be good where you kind of band together and, the competition is about making the product better and being proud of what you're doing, as opposed to competing with each other and trying to have your own ways.
Yeah, I would hope that would be, I think you just make a better game that way, at least for, in games. It seems like you have lots of smart people trying to do smart things all together, even though there's conflict. That's just teams, right?
And I always try and tell people, even if breaking into the industry is so hard. And I think that a lot of people are willing to overlook red flags during the interview process just because they want the job so bad.
Yeah.
And I always tell people, like, pay attention when you're interviewing, because if you have notice bad things happening between the people who are interviewing you, or just get a bad feeling about how things are going down there, chances are that it's going to be a lot worse when you actually have to be there every day, all day.
Yeah, it's like the interviews or the dates. And then
totally,
when you get a job,
it totally is. And
everybody's supposed to be on their best behavior.
And if they, and so, as hard as it might be to turn down that job, you might be happier if you did. And
what I always tell students, an interview, make sure it's a two-way conversation. Make sure you're figuring out if you're good for the studio, or if the studio is good for you, not just if you're good for the studio.
Absolutely.
So when you talk about working on a team and competition, and everything, what are some of the things that what are some of the things that you do as a team or on your team that make your job easier? Is it daily stand-ups or something that really work for us, or are there any specific things that's yes, this is something that I found is invaluable in my life?
So I think when you're on cross-functional teams where you have not just engineers, but engineers and designers and artists and animators and everyone, I think it's really important that everyone can speak the same language. And that is really difficult to do because everyone's work is so different. And so even though you might be asking for the same thing, you're asking for it differently, and you often could just end up talking past each other. And so it's really valuable, if it is not the most efficient thing, but I think just from a functional team thing, just to have people learn the basics of everyone else's job. And whether that's lunch and learns, where the animator just walks everyone through their workflow and says, hey, when you give me a model, this is what I do with it, and this is how I actually get it in game, and these are the things that tie me up if I don't have. Or an engineer just walking through, hey, this is how I get a feature into the game. And so that the artist can be like, whoa, that's crazy. I can't believe that it took that much work to make X feature that we both worked on, just so that people's eyes can be opened to the process that everyone else takes to get things done, and have some empathy for what everyone else is doing. Because I really don't believe that anybody comes to work today and it's just I hate everyone and I'm going to do my best job to ruin this team.
Yeah.
Right.
I love that idea, Tony, because we should put that into our projects classes, because I think we kind of just think that osmosis happens and everybody understands what's going on. But you're right. I think people are, really focused on their own stuff, even in school. And, that would make a really big
and
help.
we've done a couple of them where an animator gets up there and is like, hey, I do this. And then I have to do this manual process 17 times for every asset, and an engineer's head explodes. And he's
Right.
like, you do what?
Well, I could write a tool for you to
exactly.
do that.
He's like, let me write you a tool. And he takes one lunch break to write a tool that makes the animator's life better for the next 5 updates that we do to the game. And it's not that, the tool was hard. It's just that the engineer had no idea that there was even a need. So I think that just those little understandings can go so far in making everyone feel like they're on the same team, and just not being upset when someone asks for something that they don't understand why they're asking for it.
Yeah. I think empathy is such a critical thing
Absolutely.
for dealing with other humans in general. So
humans are overrated. We're all going to be replaced with robots soon enough anyway.
Absolutely.
So.
Well, I can't believe it, but we are almost out of time. I mean, that just went by in like that. And you probably can all hear my neighbor deciding to blow the leaves around in their front yard, that they've never done that in their whole lives before. Sorry about the sound.
Murphy's Law.
Can't hear anything on my end.
Oh, good. Well, I can. That's why I keep like muting myself here. So Tony, we try to ask everybody this question at the end, which is, if you could go back in time and give yourself advice about being a programmer, what would you say? And then the follow-up question is, like, in general, other programmers. So what advice would you give yourself?
So I always say this, and I think it's a little controversial, but I believe that generalists are more valuable than specialists, period. End of sentence.
That is a little controversial.
Yep. And I especially believe that for people trying to break into the industry. I feel like, as someone who has tried to build a lot of teams and hired for a lot of teams, the guys who I would not trade for anything in the world are the ones that I can slot into any position and know that they will be successful. So as a hiring manager, I am much more interested in someone who has an aptitude for learning, who I know can pick things up quickly and has a breadth of knowledge, than the guy who can come in and say, I know every detail about the C++ memory model. I know everything, because that knowledge has a shelf life, because technology moves fast.
Yep.
And so people who are good at learning things are more valuable than people who have learned something, if that makes sense.
Yep.
And so for me, my advice would be spend time learning new things, challenge yourself to pick up something you've never done before and make that a skill. And I know that sounds maybe ridiculous from someone who works on the most specialized team on planet Earth. But I do think it's good advice.
Made a choice, right? You've gotten I think that's why you're so good at your job, is that you have all those other skills that the people on your teams probably don't.
Right. And I think that's why I fall into the role that I do, is because I spin plates, all across the board, and I don't just do one thing. And, so I'm able to kind of contribute at a different level. And like I said, there's not a lot of people who like doing what I do. Most technical people like to stay within what they're doing. They don't like to be bothered or think about what the person next to them is doing. And that's fine, but for me, I really enjoy it. And so, like I said, get good at learning new things. And I think that you will be better off in the long run.
That's awesome.
I like that a lot.
Yeah, that's a great way to end. Thank you so much for doing this, Tony.
Yeah,
it's always a pleasure.
This is one of the most informative ones we've ever done, I think.
I know. That's why I always make Tony come and do these things.
Good on you. Yeah, seriously.
All right. Thanks so much.
Thanks, Tony.
Sure thing.
See ya.
See ya.